Our next speaker is a colleague of mine at the University of Minnesota, Len Kne, who's an associate director of the university's U Spatial Initiative, and he's going to be talking on the road with collaborative geodesign. Yeah. So, Len.
Thanks, Tom. Yes, I'm going to be talking about mobile geodesign. We've got a whole cast of characters at the university working on this. It's a transdisciplinary project. We've got people from design, from agronomy, from soil water conservation, from the Humphreys School of Public Affairs, extension, sociology. We've got just a big group working on this study. And I'm going to be talking about an area down in southwestern Minnesota, south central Minnesota, the 7 Mile Creek Watershed District. It's about 100 miles southwest of the Twin Cities metro area. The project that we're working on, and they've been working on this for a little over a year now, is looking at biofuel resource production. We're looking at engaging stakeholders. That's going to be producers, the farmers and the farm groups, agencies and NGOs of how do we get them to look at doing production in a rural landscape for food and for biomass production. Again, an emerging market there. While they're doing this, we also want to look at protecting habitat and maybe improving water quality. Here's the model that we've been following for the last year. Actually, starting out on the right side there is to engage stakeholders. And so we've been pulling meetings, monthly meetings, bringing people together, talking, having them create design scenarios. That feeds into information, into a model, which is creating design, giving back indicators, giving back performance. That's then fed back into communication loop that goes back to the stakeholders. And you've got this iterative process of people going through and working on different design scenarios to ultimately produce cellulosic, thank you, biomass. We're going to stick with calling that prairie grass, switchgrass, and corn stover. And again, there's an emerging market out there beyond just corn, beyond soybeans, of bringing in this biofuels, and they're creating or hoping to create biofuel power plants. Scale-wise, this is similar to the grain elevator that you see across the farming country. So you can get fuel out of this. You can also get pellets that are used for animal feed. And so we've got this market, and the criteria that we've given them to look at is if you replace some of the existing corn crops, can you improve water quality? So you're going to try and reduce sediment, you're going to reduce phosphorus and runoff, while increasing habitat value, market return, and carbon sequestration. So to do this, we've got a app that we bring out. This is Mobile Geodesign. Start this video up and see how it goes. It's like most web maps that you see. You can pan around, you can zoom. We've got some high-resolution aerial photography in there. One of the key things, though, is we're doing this out in community centers, and we often have no internet or very limited internet access. So we're bringing everything with us. We're bringing all the layers, we're bringing all the data and the information and the models to the people and to the stakeholders. We give them a variety of data layers that they can look at to make decisions on where they want to put practices. So for example, I'm turning on a water quality risk here, as well as critical wildlife areas. They tend to follow the creeks and some of the wetland areas. So once we've identified that, we can start drawing practices. Down in the southern area here, this is probably a good spot for putting in some prairie grass. We can protect some of those sensitive areas. As you see, I'm drawing this. I'm not being real exact with how I draw it, because the model is going to clip to the design area, so that's that gold outline. And it's also going to remove farmsteads, roads, wetlands, because we can't change those. Basically, we're working with corn. So we're going to put some switchgrass up here in the northern part of this design area. And then people save their design, and they're going to hit that and submit it. And this is where it goes off to the model. This is real time. It takes 5-6 seconds usually, and pops back with some performance indicators. On the top, you've got a bar chart showing what percentage in each practice. And then towards the bottom, you've got charts that are showing market return, water quality, habitat quality. We'll come back to some of those performances in a minute here. This is what it looks like. It's mobile geodesign. We've got large touchscreen displays. This group here is drawing switchgrass buffers along ditches right now. And as they get to the design, we're going to pop back and see. This is that design that they were working on. That design is increasing market return about $12,000 a year, so modest gains, but it's also improving water quality and increasing the habitat score. And this is collaborative. At this particular session here in a community room, we had 5 groups of 5 people each. We kind of mix the stakeholders up so they get different perspectives. And we're just zooming around. It's kind of a crazy day where lots of design going on. What's kind of fun is these these displays are on wheels. So we turn them together at the end of the day and they compare their designs and see how they turned out. The last tool, the last piece of this that we give them is a way to compare up to 4 different designs. This allows them to start looking at what are the trade-offs with different designs as you're doing this. When you hit that, you come back and you can start looking at the raw values for all these different design parameters that we're looking at. So this is that same screen we finished up on. Again, looking at it, overall can be attractive because it really increases the market return, but it doesn't do so well on water quality and habitat scores. As you start looking at some of the stover mixes here, you start getting a balance of maybe making a little bit of money, but doing some real good with some of the other services there. And it's mobile. We kind of joke that it's mobile. It's a little tongue-in-cheek because our brand of mobile requires a big truck wherever we go. It's like wheeling a refrigerator across campus and we move it between buildings. But it's mobile, sort of. They're 55-inch touchscreen displays. They all have Windows processors on them. They can be broken up into different units, so we send them individually or in groups, depending on what the people are needing. And again, for our sites, we create our own little wireless network and connect everything together for these design sessions. Quick on the system architecture, we wanted to just take something out of the box. So we're using Esri's JavaScript on the client side, some simple customization there, and using Esri's ArcGIS server to use the REST endpoints. We heard about that just in a talk this morning. That takes care of all the interactions between the client and the server. Very little customization. We do put all the modeling into a Postgres database and do most of the calculations in there because it's very fast. And again, we're working in this interactive environment. So what's next? On the technology enhancements, we have a lot of interest across the university when people see the tools and the different techniques, and they say, hey, why can't I take some of this and use it for transportation or for solar planning or something like that? So we're working on that type of change to the system to make it easier. I saw a lot of cool things at the conference here already that maybe we move towards that direction. We're looking at specific targeted performance criterias. So giving different, we've been focusing on what are the biomass production, but maybe focusing more on water quality or profitability or habitat enhancements. So giving the stakeholders some different goals that they can try and go after, all with the hunt for the optimization of food, fuel, water quality, and habitat within this one project.